So today is again trigonometry, and we're going to talk about the laws of sines and cosines. So let me just write the title down. Laws of sines and cosines. Okay, so we'll first talk about the laws of sines. Let me just draw a random triangle. Now, this is not a triangle's special properties, it's just a random triangle. Okay, that looks too much like a right triangle to convince you guys. Let me just draw a weirder triangle. Okay, so that looks better. Let me make sure my lines are straight. Okay, never mind. Let's just imagine the lines are all straight. So this is a triangle. And I'm going to label the points A, B, C. Now, usually when we label in math, we label the points, the vertices with capitals, and we label the sides opposite to these vertices, lowercase letters, like this. Okay, so we can use the vertices to represent angles, like angle A, angle B, angle C. So the laws of sines basically states that in a random triangle, like in any single triangle, in every triangle, well, sine A over side A equals sine B over side B equals sine C over side C. So that's just the laws of sines. So a bit of application might be in like geometry, like later on in geometry or something. Like when you're trying to figure out side lengths and you have a calculator so you know the sine values for something. So, like, for example, if a question says, like, given that angle A is, say, 45 degrees and angle B is 30 degrees, I'm just using these values because I don't have a calculator in front of me, so and I know these values, so yeah. And say, like, don't know, side, so angle, so, like, what is side A, B, and C? Well, let's say we're trying to find side A. Now, firstly, we know that given this and that we're in a triangle, angle C would be 180 minus 45 minus 30. So 180 minus 45 is like 135. 135 minus 30 is 105. So that's angle C. Then we can use the law of sines. Well, how? We know that sine 45 degrees over the side A, which is what we want to find, is sine 30 degrees over side B, and this is also sine 105 degrees over side C. Okay, so this is what we know, and wait, I feel like we're a bit lack on information. Okay, so let's say we need a side length. We also need that side, let's say side B is, so side B is, let's say, like 5. Okay, so since side B is 5, we can substitute that in. So given that side B is 5 in the problem, then now basically we just cross multiply this part of the equation. We don't even need this. So we multiply both sides by 5a, so this is going to be 5 sine 45 degrees is A times sine 30 degrees. We divide both sides by sine 30 degrees, so A is going to be 5 sine 45 degrees over sine 30 degrees. Okay, wait, what's this? Anyways. Okay, so what is sine 45 degrees then? That's just, so this is 5 times root 2 over 2 over 1/2. So the over 2's cancel out, and we're left with 5 root 2, which is our answer. And we can also solve for side C if we want to, so let's just do it because I'm bored. So we know that multiplying both sides by 5c in the equation, we know that 5 sine 105 degrees is equals C times sine 30 degrees. Now, unfortunately, I don't have a calculator, so let me just find one right now. Okay, but meanwhile we can evaluate this, which means that this is 1/2 c, and 5 times the sine, 105 degrees, is around, okay, let me just make this a fraction. Okay, sine 105 degrees. Wait, how do we write this in a fraction? Okay, this is around, never mind, this is just around 5 times 0.965925 if we round it up. So we divide both sides by 1/2, so we multiply both sides by 2 basically. We have 10 times this value over here. So I'll just rewrite that. That's just around 9.65926 if we round that, and that's just around C. So C is around like that. So we've solved for the triangle. We have all the angles on the side, so great. The problem is like definitely done right now. So what about the law of cosines? The law of cosines basically states that, again, in a random triangle, let me just try to make this more randomish, because it actually works for any triangle, not just like right triangles or anything. So side A, so A, B, C, side A, side B, side C. So we have so according to the law of cosines, we know that the length of side C, or actually let's do the length of side A, equals the length of side A equals b squared plus c squared minus 2bc times cosine angle A. So a great way to memorize this is that, or actually try to remember this before, like if you actually have to use it and you're studying for an all-nighter for a test, is that this side A, so we take the other sides, we square them, and we sum that up, so b squared plus c squared minus 2 times the product of other sides times the cosine of the opposite angle. Like, just try to memorize it like that. And then now let's just try and understand it so we can actually familiarize ourselves with it and we don't have to memorize. So what this essentially means if we actually apply this is that, so let's try to apply this. Well, again, let's go back to the problem we had just now. Say we know that B is, okay, so actually let's make a new problem. Say we know that B is like 7, C is 5, and angle A is 14, actually no, just 40 degrees. Okay, so again, the law of cosines is great for when you know two sides and the angle in between these two sides, like this angle over here. So we plug this in and we want A. We know that this is just going to be, A is just going to be root 49 plus 25 minus 2 times 7 times 5, which is just 70, times cosine 40 degrees. So let's just go to the calculator. So cosine 40 degrees is around like 0.766. So if we evaluate this is just like 49 plus 25 is 74 minus 70 times this value. So let me just plug that in again. So that's around 0.173648. So this is around root. So 74 minus this value is going to be around 73.826352. We round this up. And we take the square root of this thing. So let me just take the square root of this. This is around, so A is going to be around 8.59222, wait, 2226. Yeah, so that's our answer. And again, we can solve for the other angles, but I'm not going to do that here. So that's how you apply the laws of sines and cosines.